5.2b, covalent Lewis structures. What two types of elements make up ionic compounds? Metals and nonmetals. So you have to recognize the difference between ionic compounds and covalent compounds. Ionic compounds, if we were to look at a periodic table, it doesn't quite look like that. Ionics are metals and nonmetals, and covalents are two or more nonmetals. So what two types of elements make up covalent compounds? A nonmetal and a nonmetal. What type of elements tend to form cations? Those would be metals. Cations are positive. What type of elements tend to form anions? Those would be nonmetals. They are negative. They gain electrons. What type of Lewis structure involves the use of brackets? That would be the ionic compounds. There are Lewis structures for covalents that involve brackets, but we're not doing those in this unit. Covalent Lewis structures for the following molecular compounds, nonmetal plus nonmetal, draw the proper Lewis structure. Be sure to include lone pair electrons. Those are the non-bonding electrons. We'll start with H2S. The single thing almost always goes in the middle. So we're going to put S in the middle and each H on either side of that. Each H has one valence electron. The sulfur is in group 6. So it has 6 valence electrons, 1, 2, 3, 4, 5, 6. Those ones share and those ones share, such that you get a single bond and an S, and those lone pair electrons stay there. And then those ones share there, and that's your final answer. Let's move on to HCl. H has 1 valence electron, Cl has 7 valence electrons. If those two share, then we have H, Cl, and we'll count. Hydrogen needs to have 2 valence electrons, and it does. The 2 are in there. And then we look at chlorine. Chlorine needs to have 8. Remember, hydrogen's the exception. Chlorine wants 8, so it has 2, 4, 6, 8. So the answer is that. We'll move on to number 3, CH4. The single thing is in the middle. The single thing is the carbon. So you have carbon. Carbon has 4 valence electrons. There are 4 hydrogens situated around this. And the hydrogen shares the electrons with each of those valence electrons from the carbon. So you have 4 single bonds, no lone pair electrons, no, meaning no unbonded electrons. Number 4, the single thing goes in the middle, but there's 2 single things. There's the C and there's an F. The C goes in the middle. And if you're on a test and I forgot to point that out, ask me, like, is the carbon the one in the middle? And I'll say yes or no. So carbon's in the middle, and then we'll have 3 hydrogens around it. I just happened to choose that orientation, and then an F. Each hydrogen has 1 dot, carbon has 4 dots, and fluorine has 7 dots. We've seen this before. The carbon and the hydrogen share, they're quite happy. And it looks like if the fluorine and the carbon share there, then the octets or the duets will be satisfied. So each hydrogen, 2, 2, and 2. The fluorine should have 8, so 2, 4, 6, 8. And the carbon, you look just at the carbon and its bonds, and it has 2, 4, 6, 8. So it's a carbon with 4 single bonds, hydrogen, hydrogen, hydrogen. It doesn't matter where those hydrogens are. I just happen to put them there, and your final answer has to have those dots around the fluorine, or you don't get full credit. Number 5, NH3, also known as ammonia. So the single thing goes in the middle, which is the nitrogen. Nitrogen has 1, 2, 3, 4, 5, and then it has 3 hydrogens. And each hydrogen has 1 valence electron. I think that one will share. I think that those will share, and I think those ones will share. So nitrogen has 2, 4, 6, and 8. And then each hydrogen is sharing such that it has 2, because again, its max is 2. The next one, SBr3. This one looks interesting. So S is a single one. It goes in the middle. S has 6, 2, 4, 5, 6. I'm making things up. 3 BRs. And each BR has 7 because it's in the 7th group. And I'll give you a tip here. Anything in the 7th group, single bonds, that's it, that's that. So I think what we have going here is, did I get S right? S is a 2 minus, so it has 6. Oh, but I drew one too many there. It's not erasing. There we go. Aha. So this one will bond. That one will bond. And I think, did I miss something? 2, 4, 5, 6. That BR will bond. Something's going on here. This one isn't working out. I think I possibly messed up on this one. So S has 1, 2, 3, 4, 5, 6. You could definitely have a BR, which would have a lone one, and a BR, which would have a lone one, and a BR, which would have that lone one. I think SBR3 must not work. I'm going to move past it and I'll look into it. We'll do CO2. C is in the middle. Oxygens are on the outside. Carbon has 4 valence electrons. Oxygen has 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And this one, we did this one in the notes. Those two definitely will share. I think those two will definitely share. Those ones will share. What am I doing? And I think those ones will share. So what will that look like? It looks like 2 sharing there, 2 sharing there, oxygen with dots and dots, oxygen with dots and dots. Now let's see if they're happy. This oxygen has 2, 4, 6, 8. This oxygen is a mirror image of it. It has 2, 4, 6, 8. And then I'm going to look at carbon. It has 2, 4, 6, 8. They all reached 8. So carbon dioxide looks like this. BCl3. B just wants 6, remember, and it has 3. And each Cl, I'll move this one down to here. Each Cl has 7. We'll share, we'll share, we'll share. So we'll have B in the middle. It'll have 1, 2, 3 bonds. Those 3 bonds correspond to 2, 4, 6 electrons. So carbon reached its 6 valence electrons. And then we'll have each Cl, and each Cl will have its lone pair electrons. And it is satisfied. It is done. Aha, SiF4. In the middle of that one is Si. Si has 4 valence electrons. It's near carbon. It's underneath carbon. So it has 4 valence electrons. We'll orient the Fs in north, south, east, and west. Each F has 7 valence electrons. Share, 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 share. So we'll have single bonds coming from Si, 4 single bonds. Each bond has 2 electrons, so 2, 4, 6, 8. Si excuse me, has fulfilled its octet. I'm allergic to working. Maybe I'm allergic to virtual ink. Oh, this one doesn't look like it has 2, but it does. And then the Fs each have lone pair electrons in the final version. And the very last one, number 10, Al2O3. Again, when you take your test, ask yourself, Your first question, is this ionic or is this covalent? How do I tell ionic from covalent? Ionic will have a metal and a non-metal. Aluminum is a metal. Think of aluminum cans. That is about as metal as you can get. Oxygen is a non-metal. So we draw ionic compounds with the brackets. So we'll have two ALs. Each AL has a 3 plus. We'll have 3 oxygens in brackets. Each oxygen will accept a transfer of electrons from 2 of those aluminums such that they each have 8 valence electrons and each one is a 2 minus. Again, your check 2 times 3 is 6, 3 times 2 is 6, but it's opposite.